Good day, everybody. Hope I've met you well, or hope I met you well. Um, Nice seeing all of you again, though I can't see you like for real. But then it's all right. Okay, it's all right. So nice meeting with each and every one of you again. Thank you for turning on this video, trying to watch it to see what this guy is going to say and all of that. So today's lesson, I want to look at quadratic equations or quadratic functions. The thing is that quadratic equations are actually a kind of polynomial with the highest power of the independent variable being raised to 2, right? That is, it's going to be in this form, like always going to be in this form, or usually going to be in this form. So the highest power of x is going to be, 2. So whenever you have an expression, the highest power of the independent variable being 2, then that means you have a quadratic expression. So usually it's like it's ax squared plus bx plus c equals 0, right? So a is the coefficient. So this is a parameter standing beside the x squared, the one with the highest power that makes us know that this is a quadratic function. All right, so a is the parameter beside it. B is the parameter beside x, then c is a constant. Sometimes you may have the constant figure, right? You may just have this, and then you have to like work around it. But as long as the highest power of your independent variable in that question, that expression is 2, and you're talking about a quadratic equation, a quadratic expression. This is a quadratic equation because it is equal to 0. If 0 was not there, then that would have been a quadratic expression. So I guess you understand the difference between equation and expression now. Now, if the highest power of this had been 3, then you would have been talking about a cubic function. So that's a polynomial function with the highest power of the variable in it, right, being raised to the power of 3. So that would have been a cubic function. And if you have 4, they have their respective names. And if the highest power of x here is 1, then that would have been a linear function. So by a linear function, the highest power of the independent variable in the expression or in the equation is going to be 1. So yeah, that's it. Now there are different ways of solving some quadratic equations. I thank God for that, Miss Yannin, that I just did. Right, that's not a proper English in case you're watching this from outside of Nigeria. Right, I'm just talking about I misspoke like right now. So, but then um the reason why I said I thank God for that is that I am supposed to also have classes on simultaneous equations, like brand new lessons on simultaneous equations. But it's okay. So there are three known ways to me of solving a quadratic equation. So one is completing the squares method. The other one is using the general formula that some people in some areas call the almighty formula. And the third one is using a graph. You can also solve a quadratic equation using a graph. Now, this is mathematical lesson for management sciences students. So I don't think we have the same problem with mathematics students in trying to like solve like quadratic equation using graphs. Like we don't need graphs. So what we're just basically doing is we are going to solve this using different using completing the squares method and limiting ourselves to the general formula method. So I'm going to solve A, right, using both completing the squares method and the general formula method. Then the remaining two will be solved using um, the completing the squares method. All right. So for us to solve this solution, so whenever you have ax squared plus bx plus c equals 0. So what we have to do is that we have to find two numbers. That is, we have to express bx in terms of two numbers. Now, when we add those two numbers together, they will give us this bx, right? And then when we multiply those two numbers together, they will give us this. So the two numbers we are looking for would have to give us ax squared c when we multiply it. And then those two numbers must also give us bx. Must also give us bs when we add them together. So like those are the things that you need to know if you want to use completing the squares method. So like here is a question. So a, where it says minus x squared minus x plus 20 equals 0. Alright, so using completing the squares method, I need to find two numbers that when I multiply them will give me minus 20x squared, because there's a minus here. So I'm looking for two numbers that will give me minus 20x squared. And when I add those two numbers together, I'm going to get a minus x. Minus x. Okay, so how do we go about that? So what are the numbers? What are the factors of 20? 4 is a factor of 20, so 4 and 5 are factors of 20. So when I do 4 times 5, I can get 20, right? But this is minus 20, so minus 4 times 5 will give me minus 20. But then minus 4 plus 5, because minus 4 times 5 is basically minus 4 and plus 5. So minus 4 times 5 is minus 20, but minus 4 plus 5 is not minus x, is x. Minus 4 plus 5 is x. So that means I should change it. So I should be having minus 5 times 4. So minus 5 times 4 will give me minus 20, and minus 5 plus 4 will give me minus 1. Alright, so what I basically need here is this minus x um is going to be minus 5x plus 4x. That's what this is going to be, minus 5x plus 4. So all I'm just going to do is minus x squared. Now minus x, right, is going to be minus 5x plus 4x then plus 20 equals 0. It's the same equation that I've rewritten. I just look for two numbers that when I add them together give me minus x. So what do we do from this part? Why do I put a plus here? Plus multiplied by everything here is going to give me minus x back, right? So it's better to put a plus there than to put a minus, all right? Because this is basically like minus x squared plus minus x, something like that. Okay, so continue from this. I have minus x squared. Plus times minus is minus 5x. Plus times plus is plus 4x. Then plus 20 equals 0. So I now pick them. Pick this, then this, and this. Now, one thing that you must know from complete squares method is that after factorizing, the expression here must be the same as the expression here after factorizing. So what is common to both? Right, I can minus x is common, so minus x, open bracket. So here I'll be left only one x. Minus times minus here is this is plus. Then I'm left with 5 here. So if you know how to factorize, this should not be a problem. Minus x times x is minus x squared. Minus times plus is minus. Minus x times 5 is minus 5x. What's common to both sides here? I have 4 into bracket x plus 5 equals 0. So you can see that my expression here is same as my expression here. They must be the same thing. So what would I now do? The answer to this question is going to be I pick what is here and what is here. That forms a part of the answer. Then I pick either of these two. So what do I mean? My first answer is minus x. This minus x then plus this 4 that is here. Plus 4. Close the bracket. Then open another one. X plus 5, x plus 5. I just pick one of them. X plus 5 equals 0. So what is trying to say that x is going to have two answers. The first one is minus x plus 4 equals 0. The second one is x plus 5 equals 0, like since both are equal to 0. So from here, x equals 4. Then from here, x equals minus 5. So using completing the squares method, x can be 4 or minus 5. So that's it. Alright, so how then do we solve this using the general so you can keep the answer somewhere. So I keep the answer somewhere that x equals minus 4, comma 5. Using the general formula, how are we going to get this particular thing? The general formula x, which is your unknown, is minus b plus or minus root b squared minus 4ac divided by 2a. Now, what are these minus b's and whatever? Now, remember that I said this. So the thing is that the a here is the a that is here, the b is this b, and then the c here is this c here. All right. So whenever you have an expression, let's just write this expression out again. We're trying to solve a minus x squared minus x plus 20 equals 0. So be careful. Now a is equal to what is beside x is minus 1. Then b, like what's beside x squared is minus 1. Then b, what's beside x here is also minus 1. This is like minus 1x. And our constant is 20. So please be careful. So don't just go and say a is equal to 1. No, a is not equal to 1. There's minus in front of it. There's minus here too. And then plus 20, then equals 0. So from here, the whole thing is simple. If this were t, like t, then instead of having what's the formula? Instead of having an x here, we are going to have a t, like name of the variable you're looking for. So that's just the point. So applying our formula, so x then equal to minus, then b on its own is minus, so minus 1. Minus is in the formula, minus, then b on its own is minus, and plus or minus roots minus 1 squared minus 4. A is minus 1 and c is 20. everything divided by 2a. Everything is divided by 2a. So 2, what is a? A is also minus 1. So x from here, minus times minus 1 is going to be 1, plus or minus root minus 1 squared is 1, minus 4 times minus 1, that's 4. 4 times 20 is 80. So that's plus 80 now. Like minus 4 times minus 1, that's just plus 4. Plus 4 plus 20. Alright, so everything here divided by minus 2, 2 times this. So x is basically 1 plus or minus root 81 divided by 2. And the reason why you have plus or minus here is because whenever you are finding the roots of something, right, you are going to have two answers. So like root 81 is plus or minus 9. Plus 9 times plus 9, that's plus 81, minus 9 times minus 9, that's plus 81 still. So that's why you have plus or minus here. Okay, so x from here is equal to 1 plus or minus 9, like this root 81 is 9 divided by 2. So what is this trying to like let us know? That x is having two answers. As the first one, x equals 1 plus 9 over 2. The second one, x equals 1 minus 9 over 2. 1 plus 9 over 2 is 10 over 2, and this is equal to 5. 1 minus 9 is minus 8 over 2, and this is equal to minus 4. Remember the answers we got. That x is either 4, x is either minus 4 or 5. So we've gotten the same thing again. So x equals minus 4, comma 5. So for me, I would recommend that the place where you should quickly go and use this formula, like two situations where you should quickly go and use this formula is number one, where you can't pretty much think of what two numbers you can multiply and add to give you like what we did for completing the squares, like minus x squared and 20. So what two numbers can you multiply that will give you minus 20x squared? And when you add them, give you minus x. So if you can't really figure that out like quickly and then time is going, just jump and use the formula. The formula will definitely give you an answer. That's one. Then sometimes your equation would not have um whole numbers like this. So like 2 or 3, like your answer at the end of it may be like 2.7, 1.8. So how on earth are you supposed to know the two numbers that you need here is 2.7 and 1.8? So once you are beginning to realize that, okay, let's say here we had minus 20x squared, but in this place I have minus 11x. So if I multiply 4 by 5, I'll get 20, but 4 plus 5 will never give me 11, right? Then 10 times 2 can give me 20, but there's no way I can do 10 minus 2 or 10 plus 2 that is going to give me 11. So in such situations, just jump and go and use this formula, right? Now the third situation where you should use this formula is when you have decimals here, like when this is not like whole number, so you have like minus 2.4 x squared then plus whatever. Just quickly use this method and then get your answer. Then the fourth situation, which I didn't think of, it just came now, is when the question instructed you to use this formula, right? Sometimes the question will instruct you to use the completing the squares method, but if the question would want you to use completing the squares method, then that means you are going to have two whole numbers. There's a very high chance that you're going to have two whole numbers, right? But if the question does not specify what to use, then use what you um, think is best and will definitely give you the correct answer. All right. So now that we're done with this particular one, so we are going to solve this and this using just completing the squares method. All right, so for this second question, you might be wondering what on earth are you expected to do here? Because this doesn't look like a typical quadratic function, but it is, because the highest power here is 2. So to make the whole thing simpler, you can, since you have 2 raised by x, you have 2 raised by x, you can just do let y equals 2 raised by x, something like that. Like I don't want to use let x again because it is going to be somehow like let x equals 2 by x. So use a different letter. So now that we have this, so in this place now, this is going to become y squared minus 3 times 2x, that's times y, then plus 2 equals 0. Can you see how simple like this is? So let's think of two numbers. And when we multiply them, will give us 2y squared. That's 2 times 1 give us 2y squared. But this is minus 3. So I need minus 2 minus 1. So minus 2y times minus 1y will give me 2y squared. Then minus 2y minus 1y will give me minus 3y. So let me just expand this guy. So I'm going to have y squared then plus minus 2y minus 1y plus 2 equals 0. If you can't think this quickly, use the general formula. Do it this way. So y squared minus 2y then plus minus y plus 2, okay, equals 0. So I guess it's easier this way. So minus 2y, so instead of just writing minus y, so plus minus y is fine. Okay, so y minus 2 then plus I bring out minus 1. So I bring out minus 1 here. So I'm going to be left with minus 1 in minus y. This is just y. Minus 1 times y is going to give me minus y. Then this is going to be minus 2 equals 0. Minus 1 times y is minus y. Minus 1 times minus 2 is plus 2. So I have y minus 2 here, y minus 2 here. So that's good. So y plus minus 1, y plus minus 1, then y minus 2 equals 0. Y plus minus 1, that's y minus 1. So I'm going to have y minus 1, y minus 2 equals 0. So from here, y minus 1 equals 0, y equals 1, y minus 2 equals 0, y equals 2. All right, so you recall that y equals 2 raised by x. So for the first one, 2 raised by x equals 1. But from indices, we said anything raised by 0 is 1. So you can just do 2 raised by x equals 2 raised by 0. So from here, x equals 0. That's the first part. Then for the second part, 2 raised by x, 2 raised by x equals 2. So this is automatically 2 raised by 1. So from here, x equals 1. So the value for x is 0, comma 1. And if you put it there for real, this is going to be equal to 0. Yeah, so if you put 0 first, if 0 is here, 0 squared is 0. 3 times 0 is 0. No, if you put 0 here, so 2 raised by 0, that's going to give you 1. So 1 squared minus, okay, let me just try to like do this to verify what I'm saying. So I'm going to be having 2 raised by 0 squared minus 3 times 2 raised by 0 then plus 2. 2 raised by 0 is 1, so 1 squared is 1 minus 3 times 2 raised by 0, so minus 3 then plus 2. 1 minus 3 is minus 2, minus 2 plus 2, 0. Now the second one, 1, so I put 1 here, so 2 raised by 1 squared minus 3 times 2 raised by 1 and plus 2. Will it still give us 0? 2 raised by 1, so this is 4. 2 raised by 1 times 2, 2 squared minus 6 plus 2. 4 minus 6 is minus 2, minus 2 plus 2 is equal to 0. So what we did is correct. All right. So the second one is then to solve this one that is kind of looking somehow, right? It's looking somehow. So how do we go about solving this? Question 3 is a very interesting question and one has to be careful in solving it. So how do we go about it? So 3 raised by x plus, from the law of indices, right? What 3 raised by 1 minus x is actually 3 raised by 1 divided by 3 raised by x equals 4. Do you agree? You do, right? It's 3 raised by x plus 3 raised by 1. So because when this guy comes up, then this becomes 1 minus x equals 4. So you can see the way things that we've learned in the past are come into play. So from here, we can now say let's y equals 3 raised by x again. So I'm going to have y plus 3 over y equals 4. So all I have to do is multiply all through by y. So multiply both sides by y. So when I do that, multiply um, both sides by y. Some people go and look for the LCM. I kind of prefer this by y. What it means is that I'm going to have y multiplied by y, then plus 3 over y multiplied by y, and equals 4 multiplied by y. So that way, this y cancel this y. The reason why I say multiply both sides by y is because I want to eliminate this denominator. So if what was there were y squared, I would have multiplied both sides by y squared, something like that, just to eliminate this denominator. So y times y is going to give me y squared now, then plus this is just 3, equals 4y. Is this looking like quadratic equation? It is, since the highest power here is 2. So to make the whole thing easier, so y squared minus 4y plus 3 equals 0. Hope it's not confusing. Alright, so I just had to bring 4y inside and plus 3 and everything is equal to 0. So from here, is this looking like what we did um, initially? I think it's kind of looking like it's okay. So what two numbers can we multiply that will give us 3y squared, like 3y squared, and when we add them up, they are going to give us minus 4y. So an easy guess is minus 3y minus 1y. Alright, so y squared then minus 4y is going to be plus minus 3y minus 1y. Or let me just put it this way: minus 1y minus 3y then plus 3 equals 0. Okay, so y squared minus 1y, then let me write plus minus 3y, then plus 3. So because if I do this minus 3y, that will be wrong because this is not minus 3. 3 does not carry minus 3, is just on its own. So the minus is only affecting this 3y. So I could just do plus, put my minus 3y here because so let's minus affect only the 3y. So from here, bracket this one. So what's common to both? Y. So you have y minus 1 plus then minus 3 is common to both here. So you have y, then I'm still going to have minus 1 here. I believe this is clear. Minus 3 times y is minus 3y. Minus 3 times minus 1 is plus 3. So both of them are common. So I'm going to be having y plus times minus is minus y minus 3, y minus 1 equals 0. Alright, so y minus 3 equals 0, y equals 3. The other one, y minus 1 equals 0, y equals 1. So that's not the end. So recall that, where is it? Y equals 3x. Y equals 3x. So come back. Our first y was 3. So 3 raised to the power 1 equals 3 raised to the power x. From here, x equals 1. Then the other one, we had just 1, right? So 1 is same as 3 raised to the power 0. 3 raised to the power 0 equals 3 raised to the power x. X equals 0. So finally, x equals 0, comma 1. Okay. So yeah, that's it. So if there's any problem, leave your comment in the comment section. But before you leave your comment in the comment section, please go through everything we've done. Don't say because you looked at it that you already understand it. No, just practice on your own, then compare your answers to what we got. So that's how you are going to ensure that you've mastered the things that you've learned under quadratic equations. So next is just one assignment, just one assignment. So here's the assignment. To be honest, I only wanted to give one question. To be very, very honest, I just had to go and search this out. I'll give it to you, but this was what was available initially. So solve the following. Number 1, 2 raised to the power 2x minus 10 times 2 raised to the power x plus 16 equals 0. I believe by now that's just a piece of cake for you. Then applying both methods because I want to be very sure of what you've understood. So solve y equals minus 3x squared plus 6x plus 1. So just assume this is 0, like just equate this one to 0. So 0 equals minus 3x squared plus 1 So use continuous squares method to solve it. And then can you even use continuous square method to solve this thing? Figure it out anyways. If you guys continuous squares method to solve it, figure it out. Um okay. And if you guys continuous squares method, just leave it. But if you guys continuous squares method, use it to solve it, and then also use the general formula. Okay, so if you cannot use continuous squares method, maybe if you look at it and you're like, you can't come up with numbers, then use something else. This is general formula. But if you can use continuous squares method to solve it, then use it to solve it. Yeah, so that's it, and see you when I get to see you again. Bye.